Excellent. All right, again, so welcome everyone to our winter IBPSA Mixa, where we'll be showcasing some of our hackathon teams. I will note that we did reach out to all the teams and some of them weren't able to join. So there are more teams than this that participated at the recent hackathon. This is just the people who could come to this event. So there's a lot more that goes on. I'm sure we'll get to know more about the event as the time goes on. But let me introduce our first speaker, who is Alex Chapin. He is a software engineer at the National Renewable Energy Laboratory, or NREL. He has a bachelor's degree in civil engineering and a master's degree in mechanical engineering, and his experience as an energy engineer focused on energy efficiency and sustainability. And in the spring of 2022, he switched his focus to developing software for the commercial building industry. And he'll be presenting the hackathon project, Python Surrogate Model Tool. So with that, I'll give the floor over to Alex.
Thank you, Lisa. Can you see my screen?
Yes, we can see it.
Great. We called ourselves Team CalCar. We just tried to arrange the first and last letters of our names together. It was me and two other people. I was kind of go through quickly. So it was me, Andrew, and I should have looked up the last names of these people, but I'll probably try to put in chat later, and Cameron. We just got kind of paired up randomly, and our project started out it was my idea to kind of start with, and then Cameron kind of added in later. We sort of tweaked it as time went on. But I wanted to think of a way to use computer vision and machine learning to sort of automate takeoffs of 2D floor plans. We often have BIM models and all that, but usually architectural BIM models are just way too detailed and have lots of extra information that we don't need. So sometimes when I was an energy modeler doing that, I would end up just tracing out 2D images or PDFs floor plans anyways. So I was like, can computer vision help us with that? And then Cameron wanted to look at creating a Python surrogate model. And we kind of put the two of those things together so that we use the 2D floor plan computer vision to get the outline of the building. And then we finished it up with some grasshopper scripts and pollination to simulate a bunch of parametric runs of a building. And then we created the Python surrogate model, and we had all that running in a Jupyter notebook, with the idea that this would all be, if it kind of got fine-tuned, it could all be open source and something that someone could download and try to use for their own purposes. And what we focused on for the surrogate model itself was, as it says here, it was multifamily thermal resilience. So basically, it was just looking at varying different things of the building, such as overhang length and different things like that, to see what the impact would be on peak thermal loads of the building. So that was our proxy for thermal resilience. We weren't actually doing a full thermal resilience study. We didn't have a lot of time, so we were just trying to think of something that we could do really quick. And so the Python surrogate model would basically give you a way of, I can't remember what our inputs were, but basically I think it was certain aspects of the buildings, building shape and size and maybe overhangs and different things, and it would tell you the peak load. So here's kind of a general workflow I talked about already, and here's a little demo showing some of the parametric runs we looked at, varying overhang length and also window wall ratio, different things like that. And for future study, we would hope that we could expand it so that the computer vision part could do more. So right now we only did the outline of the perimeter of the building and converted that into walls and grasshopper. But we're thinking we could use OCR, object or optical character recognition to read the like room names of the rooms and try to actually bring in the interior walls as well and like the room names and try to like automate that. I was even thinking like if you could figure that out, maybe you could automate, this wouldn't really be computer vision, but like automate the like combining of rooms to simplify the model. And like if you had a bunch of offices along the south of the facade, you could just merge those into one big south office, and that would be sufficient from a thermodynamics point of view. Also wanted to include thermal model visualization in the Jupyter notebook so you could see what like the representation of what you were doing with the surrogate model and then to improve on the surrogate model itself. And that was all I had. There is a GitHub link here. It's been a while since I've looked at it, but there is, you know, whatever we did, we try to upload there. So if you are interested, you can check that out and maybe improve on it and take it and use it how you want. Thank you.
Thanks, Alec. Well, that was definitely under the 10-minute allowance that we allowed you. So I do have one question since you have a little more time in your time frame. Did you have, in terms of like the hackathon process, was it you took a drawing and then just went through the process as much as you could in the time allotted?
Yeah, we actually found some like Creative Commons images of floor plans. I think it ended up being a simple, you can the image that was like rotating through, it was, I think it just said it was like a hallway in the middle and like apartments on either side. So it was just like a really simple floor plan that didn't have a lot of, we wanted to make it easy on ourselves for the OpenCV computer vision so that it didn't have a lot of excess stuff, noise kind of in the way. Yeah, so we found an image and then we used that. And I'm actually not, I can't remember if we ended up, we got the computer vision part good enough where we were able to get the data out and use for our process. We may have, I forget if we had to just kind of manually like put that into Grasshopper ourselves at one point. Because, you know, I don't know about the other project teams, but we kind of felt like we were rushed at all times. Like there's, you know, we're on under the gun on the clock. And so we just kind of started with these big aspirations and then just kind of slowly had to like figure out what we could actually present. So, but I think we actually, you know, we did make some pretty good progress on stuff. It was just at the end, I know we were kind of scrambling to try to like piece stuff together.
Okay, great. Oh, and I will remind everyone, if you have any questions for our presenters, go ahead and put them in the chat. If we have time to address them during the presentation time, we will. Otherwise, we will save them till the end. All right, so do we have any questions for Alex? If not, Alex, I'm sure I have a lot of questions at the end and then more about the hackathon process, so we'll save those. So if you'll excuse me, I'm just gonna pause the recording so that we can skip chapters for people who wanna look at this later. All right, our next invited speaker was Ken Takahashi, but I don't see them on the call right now. So we will skip them, go to our next speaker, Anna Morton. And then if Ken joins later, then they can speak. So Anna Morton is a licensed professional engineer who shepherds sustainable design at DBHMS. As a building performance specialist, Anna works with project teams to ask the right questions and generate creative solutions. Her diverse experience enables her to think holistically, identifying the most effective systems given the project context. She also has experience with web-based programming and data analytics. Anna will be presenting the hackathon project, Electrification Optimizer. Anna, are you ready to present? Anna, if you're speaking, you're on mute. All right, Anna, we're going to go to David first and come back to you in case you're having technical difficulties. So David, is that okay with you?
Sure, that's fine.
All right. Oh, so Anna just rejoined, so give me a second. Maybe she's ready. Hi, Anna, are you there?
Yes, sorry, it keeps kicking me out, or I don't know, my browser is crashing for some reason, I think, so I apologize.
That's okay. Well, if you're ready, go ahead and present your project to us. I did already introduce you.
Oh, great. Okay, good. Yeah, so my team participated in the hackathon, and we worked on what we called the electrification optimizer. I feel like we probably could have workshopped that name a little bit, but basically the intention is to create a set of or a tool for using Open Studio to kind of quickly create different HVAC systems that would specifically be all electric. So, looking towards electrification, and then take the outputs and be able to use like hourly factors for carbon emissions based on the grid location to really get a sense for the carbon emissions of the different HVAC systems, and to make that comparison something that could be done fairly quickly. Sorry, I had these pulled up, but then my browser crashed. So let's see. So this, yeah, here we go. So this was our team who can't be here. We participated remotely, which I think maybe was a different experience than some folks. Although everyone on the team was in the same location. So we're all based out of San Antonio, Texas. So we did meet for a little bit on Friday afternoon to kind of talk through our idea and plan it out. And then there's, let's see.
Oh, Anna, you're muted, but we can see your screen. Hold on, let me see if I need to unmute you. Let's see.
Okay, yeah, sorry. I don't know why Zoom is being a little nuts. But all this to say, I think if we had more time, we probably would have spent more time kind of describing the concept and putting together a presentation. Whereas I think we really just jumped in and started, writing scripts in Ruby and just making stuff, which is maybe less of a strategy if you actually want to win the hackathon. But I guess the reverse of that is some of the stuff we wrote over that weekend, like I use that in my day-to-day work, and I know one of the other team members does too. So I feel like that's a cool, I don't know, that's a useful outcome. We have a GitHub repository. If you want to take a look, although I'm not sure, again, I'm not sure how functional most of what's up there is. But basically our application was a combination of some Ruby scripts and then a script in our studio, sort of bringing that all together for the output and showing the results. And that's kind of the conclusion. Oh, this is the team. So me, Matthew Coleman, Arsène Boudowne, and Matt Koch, who participated on Saturday. And that's it.
All right, thank you so much. And you mentioned that your team participated remotely, but the three of you or the four of you were actually in the same location. So how do you think that changed your experience?
Yeah, I think so. One of the, so Matthew Coleman, who participated, also works with me. So I feel like that, I think we had, again, I think that kind of shifted our perspective to more like practical, what's something we could write in the next, 2 days that we would actually use, as opposed to, I think, being a little bit more like visionary. But I think depending on what you're trying to get out of the hackathon, like it was really useful, right? So I think that probably influenced it some. I think it maybe made it a little more difficult to kind of collaborate with the rest of the folks at the hackathon, since we were kind of isolated. And I think if I had just been participating like online by myself, there might have been more, we might have been more quick to reach out or engage other participants virtually, right? So I do think that changed a little bit to make it more kind of our own local experience, as opposed to like more participating with the wider group. But again, I don't think that was bad necessarily.
All right, great, thank you. Does anyone have any questions for Anna right now? All right, if not, then let me just pause the recording. So I don't see Ken on the line, so I'm going to bring up our last speaker for today, who is David. He introduced himself at the top of the hour as the co-chair of the IBPSA Mixa working group, but I'll introduce him again. He's been a researcher and software engineer at the National Renewable Energy Laboratories, NREL, Buildings and Thermal Sciences Center, Commercial Buildings Research Group since 2010. His roles include feature and code development for OpenStudio SDK, OpenStudio measures, testing, documentation, support, and outreach. His recent work has focused on the development of zero energy design guides, model articulation tools to support analysis of neighborhood and district scale modeling, and advanced building construction research. David will be presenting on the hackathon project's OpenStudio measure for thermal resilience and others where the team leads could not attend today. So thank you so much, David. Take it away.
Oh, you're welcome. So thanks everyone for joining. Excited to hear more about some of the other teams, and hopefully, I can share some interesting insights about ours. So let's see, let me share my screen here. 1 second. All right, so do you all see my screen now?
Yep, we can see it.
Okay, so I won't have too many slides, but just want to pull up a few things. So I was attending hackathon, and all of our team members were in person. We had attended, the conference in Chicago, VPAC, and so this was right after that. We didn't go into the hackathon as a team, and we didn't have any specific ideas on what we wanted to do. So it took, we didn't have any preconceived notions of what to do, but all of us kind of settled on resiliency for buildings as something that was very important. Isn't something that was typically in people's workflow, and had some limitations with some modeling tools on how that's simulated and how it's modeled. So, I've kind of covered part of what was on this slide, right? Normally, if you want to do a resiliency study, it's not something you get out of your 8760 simulation. You have to make a point to do a separate analysis. Everyone's typically working on a tight budget, and unless they're required to, like 209 or something else, they won't do this. Not because they don't care about it, but because they're trying to make their workflow as quick as possible to get just to the answer they need. So in addition to being able to do the simulation itself, we wanted to look at survivability metrics. This was in September before all the recent winter storms, and so obviously we learned and knew before that life safety is an issue both for winter outages and for summer outages. And so that's the most critical element we cared about. But there's also how you can have something that's survivable for a person, but will still cause damage for the building. And then there's expense and carbon footprints to tear things out and replace them when parts are damaged. So we care about both of those. avoiding damage to the building and protecting life and health of people inside the buildings. So when we started this, there was interest in making this easier. And so because I work at Enroll, I was familiar with a project that was done for residential resiliency, where there was an open studio measure, but it was specifically made for HPXML based OSMs. And so I was able to use that as a starting point. That measure has not been published yet, but the intent is that it would be made public, but it needs some more documentation and testing. And so I was also, as part of the hackathon, trying to extend that measure to be more general use for any model that was passed in, instead of specifically models that were based on an HPXML. So for example, originally there were some string searches for zones of a certain name or something, and I've tried to replace those with something that would work for any sort of building. And then even within the Open Studio measure, the metrics we get out are for, right, it's a well-mixed air zone with a single temperature for that zone. And so Chris Mackey had done work in the past and others on Ladybug tools to be able to do a higher fidelity metrics, spatial metrics within this spatial fidelity. So you can know there might be different thermal comfort right near a window or in the center of the room or near a wall. And so we ended up kind of working on these two separate things and didn't tie them together. But at some point, we want to be able to run this measure through Ladybug tools or bring the Ladybug tools measure directly into an Open Studio workflow so that it can be used, for example, in a parametric analysis in PAT. Of course, pollination could be another way to do that. So we didn't completely finish. I guess that's the nature of the hackathon sometimes. And just as an example, these charts aren't all that useful, but I have flood plots at the right that show the whole year. And we're looking at like a few day period here in winter where it's all blue, where we turned off the power. And so the building got really cold. And we were looking at outside temperature versus the inside temperature. And as an example, here's one of them in summer where, then we had the outage in July. So the way, I'm going to actually jump something else here for a minute. I started a little mural diagram. Yeah, so the way we did this is we wanted to develop a reporting measure because you still need to get your 8760 results. So you know what your building UI is and all the other metrics you care about for business as usual. But then we wanted to spin off both a summer and a winter copy of the model. For our use purposes, initially, we used the standard weather file and we manually selected the outage period for what was the worst. But we would like to automate that process in the future, or potentially like look for extreme weather situations beyond what would be in the typical weather file. So there's definitely room for improvement on how we apply, which weather we choose, and how the outage location is determined. Another addition we did is we said, well, right, if it's hot, we know that there's passive things you can do. Well, not completely passive, but you can open the windows, right? And that's going to improve the comfort in the space when it's hotter inside the building than it is outside. Not only, right, you're getting wind, but you're also, if you're getting any air mixing, you're right letting the temperatures equalize. And then in winter, potentially you could put in window coverings, even if you don't have them, then right, you could put curtains, blankets over the windows. So we wanted to look at ways that you could improve it, the comfort with what you have available in the building. So once, so we basically copy the model, we apply those measures. Then this measure that turns off the power, basically it alters the schedules, but it, for example, can leave like people on. So you have the heat from people, which right in winter might help you and in summer fights against you. But that could be altered to get, like if I were designing winter outage, I might not want to assume there's 20 people there. I might want to assume somebody's there by themselves and do a worst case scenario. So then those feedback in, ideally eventually through Ladybug tools to provide again higher spatial fidelity, and then that feeds back into the standard report that everyone's looking at. So the goal is that along with my EUI that I'm looking at, I can automatically have these resiliency metrics and one of the concerns is there are certain times people are trading off, like for example, PV versus more insulation or change the tightness of the envelope. And if they look at it as business as usual, you don't really understand the impact it has on these emergency situations where, which as we're seeing happen more often, than people might expect. And so our goal here, is to give more data to people early in design so that it's not something just done at the end of the project where, it's too late to really change anything, right? You can't put more mass into the wall when you're already in construction documents, when you find out that you want more resiliency. So it should be something that's thought of, from the beginning of the project. And so anyway, we do have a GitHub repository. Currently though, it's in Al's PhD GitHub repo, which I don't think is where we eventually want it. So if anyone wants to get access to that, I can talk to Mitchell, Al, and get that. But we'll probably find a better spot to put it for future work and write more documentation. But thanks everyone for listening.
Yeah, thanks so much, David. Did you want to talk about some of the other projects that weren't able to attend today?
Sure, yeah, let me share my screen for a minute for that. So let's see. So this is I'm not sure if we can, this URL, I think this URL is public, but these are the different projects we had. So we have people here from the team I was on and then 3 other teams. So most of these, in fact, all of them, I guess, have a link to different presentations. And I wasn't necessarily going to open these up here now, but maybe I'll try to put this in the chat and people can do that. And some of these even have the GitHub repos. So let me first see if I can, let's see if I can, yeah, I think I can share my screen and put in a message at the same time. So let me know if this doesn't work for people, but I think if you find something that a team is doing is useful, you'd like to, support that. The idea is that these projects could live on and beyond the hackathon. The hackathon was just kind of something to kind of do an initial test and see if there's value and if there's an approach, and then continue to work on it if it seems like it's would benefit from additional features or more robustness. But anyway, I think like one of these was with thermal and carbon simulation. Yeah, well, Matt's here. Design Better Sim Build was a separate one. That's more about how to hack the sim build or conferences to make them more interactive and in the future. So I did see Matt's on. He can always talk about that later if we want to. There's another one on CFD. And let's see. Immersive. Oh yeah, I think we had one here that was, this might be using a headset to do, I might be getting mixed up. No, I think this was it. So this was taking simulation results and putting them into a VR headset. I'm particularly interested in kind of taking this slightly different direction and doing it for augmented reality, where you have an existing physical building and you have, it could be measured data or it could be simulated data that is with energy efficiency improvements, but then you can overlay that, onto what you're seeing here. And here you can see on the ground, they've overlaid thermal comfort to see that, right, you can see by the window, right, there's, I don't know if that's actually thermal comfort or that might just be daylight. But the point is you can see it in context, in an immersive environment instead of just on a screen. So that seems really interesting. Let's see if there are other ones on there. I think we've mentioned most of them. So anyway, this link was in the chat. So if it doesn't work, let me know and we can get you contact information for any of the teams. But I think most of them probably have it on their GitHub page or in their presentation.
Great. I didn't see the link in the chat, so you want me to post it?
Oh yeah. Somehow I did a direct message to one person. I'm not sure.
Okay.
I'm not sure how that happened. Let me try it one more time. Send chat to. I don't want a direct message. Everyone in the meeting. Okay, one sec. You think after 3 years I know Zoom better? All right. Do you see it now?
I do not.
Oh, that's so weird. Look at everyone in meeting. Let's try third try.
Okay. Oh, there we go.
Okay.
All right.
Okay.
So someone did ask about the presentation shared today. So I think if people click on that Google Doc spreadsheet, they should be able to get the slides.
Right. I think I don't know, like in mine, I showed that mural diagram, which that wasn't part of it, but and I don't know for sure if Alex and Anna matched. They might have changed things from what was done at the hackathon, but I suspect they should be very similar.
Yeah,
What was
if
presented, yeah.
Anna and Alex want to chime in here about what they presented and what's on this spreadsheet.
It's for me, it's exactly the same thing. So
Excellent.
no changes.
Excellent. How about you, Alex? Was there any change that you wanted people to know about?
Yeah, for me, it'd be the same. I didn't work on anything after the hackathon. As a side note, though, we did have Andrew Rivera. It was interesting. He found out about the hackathon somehow and joined virtually. I was virtual, Cameron was in person, but Andrew came from more of the computer science background and was unemployed and came to the hackathon hoping that he could work on something that would maybe lead to him starting a company or use that as like a resume builder. And he was trying to get me and Cameron to start a company with him based on what we did. It didn't pan out, but so I don't know if he may have like worked on it a little bit. I haven't talked to him about that specifically, but so I don't think there was anything changed, but I think it's possible that maybe he did something.
Right. Thanks everyone for your presentations. I know they were brief. They're probably even briefer at the actual hackathon. But I wanted to just like back up a few steps for anyone, maybe just like me, who doesn't quite understand what the hackathon was, and what was the structure, what was the purpose, because it sounded like some of you were more like pie in the sky. Sounded like Alex's project was more pie in the sky, and then Anna's project was more, we want to develop something that we can use, and they're actually using it. So it's kind of cool. So I don't know which of you thinks they're the most familiar with hackathons and can kind of give us a rundown of what it was, kind of paint us a picture.
So it was the first one I did, so I don't have a lot to compare it to. So if someone else has done more, they might have better insight. But if not, I can. I mean, I felt it was very open to what you wanted to get out of it. So like the guidance on what your hackathon topic could be, could be anything. It had to have some connection to building some performance. But I think people were right there on their own time, and so it's kind of like, what do you hope to get out of this? And so I think that might have varied. Some people just like the idea of the competition, and that's fun. And some might have been more focused on something that they've wanted to have a tool for a long time and haven't had time, to sit down and do that. It was a very interesting facility too. It was really cool, like old industrial building that this guy does research on mushrooms and other substances that he does for I guess a lot of companies. By the way, I think we are still recording, which is fine if we want to, but if we want to, we could also have open discussion without recording as well.
Yeah, I was just about to stop the recording so people can